All right, so number 5, angle BDA is a straight angle. Find the measure of angle ADC. So are my two angles congruent? No. What would be in the directions if they were? Bisect, and it's not. What would be in the picture if they were? Yeah, the little arcs. Okay, we don't have those either. What is important in the directions? Straight angle. What does that tell me?
It's 180.
Yeah, so BDA is 180 degrees. So we're going to take the two inner angles and add them up. And what will they equal? 180. Perfect. So realistically, when I set this up, do I need plus -6? No. Okay. So I need to combine like terms. Minus 4x minus 6x makes -10x. Plus 42 plus 8 plus 50. My next step. Subtract 50. Good. So we have -10x equals 130. Divide by -10, and what does x equal? -13. So can I have a negative x?
Yes.
Yes, I can. Can I have a negative angle? No. So I need to plug in for ADC, because that's what it says in the directions. So in the picture, the measure of ADC is -6 times x plus 8. What am I going to plug in instead of x? That -13. When I multiply my negative times a negative, what's going to happen? Becomes a positive. So 6 times 13 is? 78. And then plus 8 is 86 degrees. The second, in the diagram, RT bisects SRQ, and the measure of QRT is 54 degrees. Find the measure of SRQ. So what's the important, there's two important pieces of information in this problem. So what are they? Bisects. That tells me it cut the angle in half. And then the 54. So we're going to go ahead and write that in. QRT is 54 degrees. And if SRQ was bisected, what's the measure of the other piece of SRQ? It'd be 54. So then what do we do to find the measure of SRQ? Add them together. 54 and 54 make 108. Good. If you're going to draw one more on this paper, remember you need all 7 completed for your notebook check. When do we do notebook checks?
Test day.
Yeah, your test day. When is your test?
Thursday.
Thursday. Okay. All right, go ahead and draw this one. I'll wait for you. All right, so it says in the diagram, DC bisects angle BDA. Find the measure of ADC. So what's the important part of our instructions? Bisects. So what does that tell me about my two angles? They're the same. They're congruent. So BDC is going to be congruent to CDA, okay, because the outer angle is bisected. So what do I do with my two algebraic expressions there? Yeah, set them equal. What's my smaller x that I can move? Yeah, 7x. How do I move it across the equal sign? Subtract it. So I have 2x minus 37 on the right. What do I need to move next? Yep, I'm going to add my 37. What's 37 minus 19? $37 minus 19? It's 18. It's okay. It's a Monday. Divide by 2 and x equals 9. Alright, but it didn't ask what x was. It asked to find the measure of angle ADC. So what is the value of ADC in our picture? Yep, 9x minus 37. So I'm going to plug in that 9. 9 times 9 is 81. Minus 37 is 44. So if ADC was 44, what's BDC? 44. So the whole angle, if you add them together, BDA is 88. A lot of students asked me this morning, they said, does this angle equal 90 degrees? It doesn't. You can't just assume it does. Unless it had what in the picture? Yeah, a little square in the corner. Then you would know they add up to 90. Had you added these up to 90, do my two angles actually add up to 90? Yeah. They add up to 88. Okay, you would have been wrong. And it would have been a lot. Okay, so make sure if you see the word bisects, you just set them equal, and you count your blessings. Go ahead and take out 1.6. Go to page 2. You'll also need highlighters for today. Why would you staple the paper? Don't be wasting my staples. So we're on page 2. You'll find a picture that looks just like this. You want your notes out? So we're on page 2. All right, name a pair of complementary angles. What did complementary angles mean to us on Friday? What do they do? Yeah, they add up to 90. This is my calligraphy. Add up to 90. Add up and equal 90. So we're finding two angles that add up and equal 90. You're going to go ahead and write comp. You can write complementary if you want, but it's asking for 3 different things, so you need a label to make sure I know what you're talking about. So we need 2 angles that will add up to 90. Which angle will never add up to 90 in numbers? Yeah, 131 will never add up to 90. So then all we have left are 41 and 49. What's 41 plus 49? 90. So are they complementary? They are. So we're going to name them. How do we name the 41 degree angle? Yep, FGK. All right, and then name the 49 degree angle. GKL, sure. Or I could say LKG, same thing. The next thing we're going to find are my supplementary angles. What do supplementary angles do? They add up to 180. So again, I'm going to write my calligraphy. Add up and equal 180. So I'm going to erase what we've had. We know 41 and 49 add up to 90. What about 41 and 131? Do they add up to 180? No, you can tell that by the picture. If they did add up to 180, what would they look like together? A straight line. They don't. And then obviously they both end in 1, and 1 plus 1 is 2. So that's not going to make a 0 like we need for 180. So what's the only other combination that will add up to 180? 131 and 49. And they do. So we're going to go ahead and name the 131 degree angle. What do we name it? Sure. So supplementary angles. Angle H. HGK. All right, and then we're going to name the 49 degree angle. Sure, GKL. Angle GKL. The last thing are my adjacent angles. Adjacent angles don't have a measurement requirement. What is the only requirement for adjacent angles? They share something. They share more than just a vertex. They share a wall. So technically they share a vertex and a side, or you could just say they share a wall. Both same thing. So adjacent, so I'm just going to write ADJ. So what do we think? HGK is one of them, yep. Angle, oops, sorry. Yep, I just outlined the wrong one. You're still right, HGK. All right, and then what's the other angle? FGK. Good. Good, good. So now we just answer some questions. Are KGH, so I'm going to highlight, well, I'll do yellow. KGH, can you see the yellow? Okay. KGH and LKG, so LKG. Are they adjacent angles? So Landon actually just said it. The technical definition of adjacent angles is that they share a vertex and a side. Normally we can just say a wall, but do they share both a vertex and a side? They don't. What's the vertex of the 131? G, and what's the vertex of 49? K. So they don't have the same vertex. So you're going to say no to the first one. Okay, no, they don't share a vertex. I would say they don't. They don't share a vertex. The next one's even weirder. It says our FGK and FGH adjacent. They're not. So they're no. Because they need to have the wall between them. If that makes sense. So like Miss Belk and I, if you look at our rooms, this is me. This is me. This is Miss Belk. Okay. The reason that we're adjacent is because we have this literal wall between us. There is no wall between the two angles. The angle, you're measuring like the corners. So the only thing that can be adjacent to these two angles would be the wall between their angles. Okay? So it'd be a no because the wall is not between the two angles. Okay? The last two have nothing to do with the picture. You'll just see a problem that looks like this. These are like fluff questions. Does anybody know what I mean by fluff questions? They're like easy. They're like, here's a... If you don't get it, then it's like, all right, there was nothing I could do for this kid. Like, it just is what it is. You know what I mean? I don't know. So it says angle 1 is a complement of angle 2. What does complement mean to me? They add up to 90. So angle 2 is 5 degrees. Find the measure of angle 1. So what would I do to find the measure of angle 1? Subtract from 90. This one's easy. 90 minus 5 is 85. So the complement of 5 is 85. The complement of 10 is... The complement of 10? 80. Okay, so on and so forth. The next one asks for the supplements. So what do supplementary angles do? Add up to 180. So you have the measure of angle 3 is 148. How do we find the measure of angle 4? Subtract from 180 and we get... Yep, you're right. 32 degrees. Good. I think we do this last one before we move on. Students off the bat don't like this problem until you understand the problem. So, what does the first sentence say? Good. So, what part of that sentence is the most important, do you think? What does complementary mean? They add up and equal 90. So, guess what we were just told? We were just told that the measure of angle LMN plus the measure of angle PQR, what do they equal? 90. That's what that first sentence just told us. Okay? Find the measures of the angles when the measure of LMN is 4x minus 2 and the measure of PQR is 9x plus 1. So what do you think we do with these algebraic expressions? Yeah, we're going to plug them in, and then they equal 90. We're going to plug in LMN. What's the measure of angle LMN? It tells us 4x minus 2 plus, what's the measure of PQR? 9x plus 1. And they equal 90. So all we did was plug in what the measures equal. All right, so what's our next step? They're on the same side, so we're actually going to combine them. So no subtracting. What's positive 4x plus 9x? 13x. And then minus 2 plus 1? Negative 1. And they equal 90. My next step, add 1. So I have 13x equals 91. My last step, I want to get x by itself. Right now it's being multiplied by 13. The opposite of multiplying is dividing. So x equals 7. Have I answered the question? No. What does it want us to do? Find the measures. So we're going to find the measure of each angle. So what are we going to end up doing with x? Plugging it back in. Good. So the measure of LMN is 4 times x minus 2. So 4 times 7 minus 2. 4 times 7 is 28. Minus 2 is 26 degrees. The measure of angle PQR is 9 times x plus 1. So 9 times 7 is 63 plus 1 is 64. All right, so what's a way to check myself? I just saw Jimmy do it. What do we do? Add them together, and what should they add up to? 90. Okay, and they do. All right, so go ahead and flip. You're going to learn 2 more words. These are words we're going to use the rest of geometry. First one is a vertical angle. It's going to show you the official definition, but you're not going to write down the official definition. You're going to write down what I tell you. Okay, so vertical angles are angles. Let's go ahead and write it in. That share only a vertex. They are across from each other. and are formed by two straight lines. I know it is a long definition, but the official definition doesn't normally help students. But you're looking for these three things. They share only a vertex, they are across from each other, and they are formed by two straight lines. What's a way to remember that they share only a vertex? Think of the word. Yeah, vertical and vertex are very similar. Pretty sure it's where they got vertical from. All right, and they are across from each other. And they're made by two straight lines. This is where you're going to use your highlighter the most. Okay, vertical angles. We'll talk about it. So the official definition doesn't really help students be able to identify them. Vertical angles only share a vertex. So let's start with angle 1. Let's just do this. What letter does vertical start with? A V. So you want to think of the letter V often. So you're going to color angle 1 exactly like I colored it. So you're going to outline the rays, put an arc. I'll show you why you do that. Okay, so outline. And then put the arc. If you don't write the arc, you will not understand your notes. So I would draw a little arc that I did. What is the only angle that angle 1 shares only a vertex with? Meaning it doesn't share a wall, it's not right next to it. Angle 3. So you're going to take that same color and highlight angle 3 in the same manner. Angle 1 and angle 3 are vertical to each other. And I'll explain why with the definition. So angle 1 and angle 3. They share only a vertex. What do angle 1 and angle 2 share? They share more than a vertex. What else do they share? They share a wall. Okay, so they're not vertical. They're also not across from each other. Angle 1 and angle 3 are the only ones, well, not the only ones, but they share a vertex. They're across from each other, so they're across the vertex from each other. And then they're formed by two straight lines. Here's what that means. You could draw a straight line outlining both angles. Okay, so that's angle 1 and angle 3. Angle 4, if you read, angle 4 and angle 2 are also vertical because they only share the vertex. So with a separate color, you'll highlight 2 and 4 the same. So they only touch by a vertex, these blue ones, only touch by a vertex. They're straight across from each other from the vertex, and they're made up by two straight lines, same thing. Then I'm going to have you draw a separate picture. Something like this. So in that blank space next to it, I'll have you draw a new picture that looks like mine. I draw it with your pencil, your pen, whichever one you're using. I'm going to show you a more complicated version of vertical angles. So if you're not seeing it, you will start seeing it. Okay, we're going to name the angles. So on the side in the white, you should have drawn whatever. Okay. So draw this picture. We'll name the angles. So 1, 2, 3, 3, 4, 5, 6. So at this point, you can use the highlighter if you want to. If you don't want to, then that's up to you. But angle 1, here's a simple way to do it. If you followed the rays that make up angle 1 and continued straight through the vertex, it outlines which two are going to be vertical. So what will be vertical with angle 1? Angle 4. So again, if you don't want to highlight, I would just write angle 1 and angle 4. We're still in this section. It's okay. You're just going to get a little, probably confused. So angle 1 and angle 4. You can do the same thing with angle 2. If you drew on the rays of angle 2 and continued, what will angle 2 be vertical with?
5.
Angle 5, good. And then you could probably deduce angle 3 will be vertical with 6. Okay, same reason. All right, so vertical, they only touch with a vertex. I told you the letter V because you'll just see a bunch of V's. Okay, that's a way to look at it. What you need to know about vertical angles, I would write it and highlight it because it's super important, and then you'll see it the rest of geometry, and it'll be assumed that you know what it means because we learned it in chapter 1. Vertical angles are congruent. I won't pull it up yet just in case you're not finished with my picture. Vertical angles are congruent. I would write it down. So vertical angles are congruent. So angle 1 and angle 3 are congruent. Angle 2 and angle 4 are congruent. So I'd write it and then I'd highlight it so you know what to look at. What does congruent mean? Same measure. Okay, so here it won't be same length because angles aren't a length. They're going to be a measure. So whatever angle 1 is, if angle 1 was 150 degrees, what other angle would also be 150 degrees? Angle 3. Okay. So vertical angles will be the same measure. Then we're going to move on to linear pairs. Linear pair, oh, no, vertical angles. This is what you see in a railroad crossing, hopefully in your life. These two angles are vertical. These two angles are vertical. Because they have two completely straight pieces of metal crossing, it forms vertical angles. Okay, so that's where you'd see them in real life. Linear pair. So you're not going to write down, again, you're going to write down my definition. A linear pair, there are two adjacent and supplementary. Hopefully you can read it in the purple. It is what it is. Adjacent and supplementary angles. So two adjacent and supplementary angles. So two adjacent and supplementary angles. Two adjacent and supplementary. Adjacent and supplementary. So you have this picture. You have this picture. What did adjacent mean? Adjacent? Yes, close. They share a wall, so a vertex and a side is the official definition. So they're adjacent, and then they're supplementary. What did supplementary mean? They add up to 180. So two angles that add up to 180. So basically you're going to have two angles that are next to each other because they're adjacent, and they're going to add up to 180 degrees. What does 180 degrees look like?
Straight.
A straight line. So what's going to happen? If you see, you have this picture. Angle 5 and angle 6 are a linear pair because they form a straight line together, which is how many degrees? 180. And then they are adjacent, which is they share this wall. Okay? So I'm going to show you on your other picture. You should have this one as well. You may or may not want to use colors. Maybe use it on one and then just list the rest. Okay? Because there are a lot of linear pairs on this picture. Okay? So again, maybe use one color and then just list them. Because it gets confusing if you're not me. Capiche? Why are you looking like that? Did you even write what I asked you to write? Can I repeat what? I wrote it up there. Okay. So here's how you find a linear pair. What is the root of linear? Line. Okay. So if you find a straight line, like so. So this is the only one I would highlight. There are many pairs, but again, it gets confusing with all of the colors. So I would just do this one. These are a linear pair because they share a wall. This makes them adjacent. And then they form 180 degrees with each other. Okay, so linear pair, angle 1 and angle 2. Those are the only ones I would highlight if I were you. Just angle 1 and angle 2. But there are more. I would just list the rest of them. So another pair, again, I would just list them at this point. I would not actually draw the colors. So we had angle 1 and angle 2. What else is angle 2 linear with? Angle 3. Angle 4 is not adjacent to angle 2. So angle 2 and angle 3 are also a linear pair because they're adjacent, because they share this wall, and they form 180 degrees together. So again, I would just write off the side angle 2 and angle 3, so you don't have a billion colors everywhere. So angle 1 and angle 2 are a linear pair. Angle 2 and angle 3 are a linear pair. What else is angle 3 a linear pair with? Angle 4. So angle 3 and angle 4. I'll do this instead. Angle 3 and angle 4. Because again, they share this wall, which makes them adjacent. And then they form 180 degrees together. So you should have angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4. And then the last pair would be, angle 4 and angle 1. Angle 4 and angle 1. Okay? Because again, adjacent, because of this wall they share, and then they start and stop on a straight line, which makes them 180 degrees. Alright, so we are going to do this together. It is what it is. All right, identify all the linear pairs and all the vertical angles. So, start with linear pairs. What do linear pairs look like? This is what my students used to say. They look like an upside down T, or they could look like a right side up T, or they could look like a sideways T. Okay? Here's what you want to look for a linear pair. Linear pairs are adjacent and they form a straight line. So you want to be looking for a straight line. So the vertex is in the center. You want to look for a line that goes straight through the vertex. There are two of them. So I'm just going to highlight one of them. Okay? I highlighted one. You don't have to highlight. We're just talking. I would not highlight. Don't confuse the picture. A linear pair are how many angles? How many are in a pair? Two angles that are adjacent and form a straight line. So here's where a lot of students start off and say, well, 1 and 3 are a linear pair. They are not, and I'll tell you why. 180 degrees looks like a semicircle. Okay, we all agree? Angle 1 is this piece, and angle 3 is this piece. Did I account for the entire semicircle? So a lot of people skip out on angle 2. So how many angles are right here on the top? 3 angles. But how many are in a pair? 2. So this is not a linear pair. The top, there's not a linear pair at all. The bottom, however, how many angles are there? 2. They're next to each other. They're adjacent. Okay? And they start and stop on a straight line. That means they're also together. They're supplementary. They're 180 degrees. So my first linear pair would be angles 4 and angle 5. Okay, does everyone see the T? The letter T? if I wrote test next to it, EST, test. Okay? So that's what a lot of students look for, an upside down T, or a sideways T, or a right side up T. Okay? We're going to look for another pair of linear pairs. Is there another straight line that goes straight through the vertex? Yes, there is. There's one more. Okay, how many angles are on the left portion? There's 2. It's not our bill. That's pitiful. So does everyone see the sideways T here? Okay, so we have, they're adjacent because of this wall, and they start and stop on a straight line. That means this is 180 degrees. So that means they're both adjacent and supplementary. So that means they're a linear pair. So we would name angle 1 and angle 4. If you looked at the top, again, how many angles are there? 3. So there's no pair up here. There's 3 angles that make 180 degrees together. So the only 2 pairs are 1 and 4 and 4 and 5. Last thing to do are vertical angles. Here's an easy way to find them. Vertical angles share vertex. They're across from each other. They're made by 2 straight lines. So here's what I tell people. If you look at angle 1, if you outline, you don't have to do it on your paper, just look at mine. If you outline angle 1 and keep going, okay, vertical angles are formed by 2 straight lines. This will highlight the 2 vertical angles, or the vertical angle with angle 1. So which angle is vertical to 1? 5. They're across from each other. They only share a vertex. Okay, they're going to be congruent. Angle 2, if I tried to do the same thing with angle 2, I would draw this straight line. Does the other ray of number 2 go straight through the vertex? No. So angle 2 doesn't have a vertical angle because this straight line would have to keep going, okay, in order for them to be congruent. Some people would say 4, but do they look like they're congruent, 4 and 2? Do they look like they're the same slice of cake? They're not, okay? They have to be formed by 2 completely straight lines, meaning if you were to draw vertical angles, you draw 2 straight lines. This is vertical to this one, and this is vertical to this one, okay? What about angle 3? What do we think? Yeah, there isn't a pair. Because again, this line stops at the vertex they all share. It doesn't keep going. Okay, so the only way for 3 to have a vertical angle was if there was a line that kept going. Okay? Go ahead and flip. All right. 2 angles form a linear pair. So you're going to draw a linear pair. So it helps if you look at the one we just drew. What does a linear pair look like? An upside down T. So you're going to draw an upside down T. So I would draw one. What do we know about linear pairs? There are 2 things. They're written on the board. They're adjacent, and what are they? Supplementary. What does supplementary mean? They add up to 180. Okay, so these 2 angles are going to add up to 180 degrees. Okay, that's what supplementary means. All right, so now we just read. The measure of one angle is 5 times. When we say times, what mathematical property are we doing? Multiplication. So we're going to do 5 times something. Okay? What are we 5 timesing? The measure of the other angle. Do we know the measure of the other angle? No. What do we call things we don't know in math? In algebra, we call them x. Okay, so one of our angles is 5x. What does x represent? The other angle. The other angle. So here's what that means. We named one of our angles 5x. Okay, because the measure of one angle is 5 times the measure of the other. What do we call this other angle? We call it x. Here's the most common mistake, and I guarantee you this question is on your quiz because I just took it this morning. Most people get 5x, and then that's it. They get that and they move on. But if you only put 5x equals to 180, you're not going to get the correct answer. What do we know about these two angles? We've already talked about it. What do? They add up to 180. So you're going to do 5x plus x equals 180. Okay? Most people, the mistake they make, I'm telling you, most people are going to do this tomorrow. They're going to say 5x equals 180. If this was the case, your picture would have looked like this. It would have been one angle, and that one angle would have looked like 180 degrees. Okay? We have a linear pair. How many angles are in a linear pair? 2 angles. So you need to make sure you name 2 angles in this equation, or your answer will be wrong. It'll just straight up be wrong. Our next step, we have 5x and x. What's 5x plus x? 6x. And it equals 180. So last step, x equals what? 30. So one of our angles was x. So we already know one of our angles. Okay? Because we named this angle x, and it's 30 degrees. How do we find the measure of the other angle? You can subtract, but if you're wrong, what else could you do? You could plug it in, yeah. 5 times 30 is 150. So your 2 angles are 150 and 30. Your problem will look very, very similar to this. Okay, so what is the main thing not to forget? We've already talked about it. Name both angles. What will one of your angles always be named? X. Okay, don't forget it. We're going to stop here for a minute. I'm going to show you your homework. Do not put it away. 1, 2, 3, 4, 5, 6. Alright, so everyone take one and we'll talk about it. So the problems that you're doing are 1 through 20. So it sounds like a lot, but only about 5 of them contain any math whatsoever, any numbers. So the first 9, you're actually circling which ones apply. Just put it on the back table. 1 through 20, the numbers start over on page 2. You're only doing 1 through 20 up until this problem on page 2. Okay, just so you know. There's something that you need to fix. Don't cross out the other ones because we are going to eventually do them, just not tonight. Here's what you need to fix. I need you to notice it. I'm not going to tell you right now. Read the directions. It says circle each pair of angles as adjacent, vertical, complementary, supplementary, or a linear pair. It can be more than one of these relationships. Look at my number 1 and compare it to your number 1. What is yours missing? It's missing the word vertical. So you're going to have to write in the word vertical as an option for all 9 of them. Go ahead and do that. So you're writing in the word vertical as an option. This was not multiple choice until I made it multiple choice. So I'm sorry it's not there, but it used to never be there, so none of these should ever be there. So you're writing vertical as an option for all 9 of them, 1 through 9. That doesn't mean all of them are vertical. That just means you're picking. They might be vertical. All right, so then here's what you're going to do. Can you have more than one answer? Yes, it says it's possible. Okay? So, number 1, you go through and you ask yourself, are angle 1 and angle 2, are they adjacent to each other? Yes, they are. So you'd circle the word adjacent. You'd move on to the next word. Are they complementary? Is there anything telling you that they add up to 90 degrees? No, so you wouldn't circle that one. Are they vertical? No. What does a vertical angle only share? A vertex. These share a wall. Okay? What I want you to know, I would write it down somewhere. If they're adjacent, adjacent angles can't be vertical, and vice versa. If it's adjacent, it won't be vertical. If it's vertical, it won't be adjacent. So, okay, so and vice versa. Because what does adjacent mean? Adjacent means they share a wall. And what do vertical angles only share? Only share a vertex. So they cannot be both. That makes sense. You'd keep going. Are they supplementary? Do they add up to 180 degrees? No, they do not. What does 180 degrees look like? A straight line, okay? And these do not. All right, and then are they a linear pair? No. So this one happened to have one answer. They might have more. Here's what else I want you to write down. It would be smart. By definition, what is a linear pair? Yeah, they're always adjacent and they're always supplementary. So anytime you circle, anytime you circle a linear pair, it will also be supplementary, but it's not vice versa. So anytime you circle linear pair, you will also circle supplementary. Because linear pairs, by definition, are supplementary angles. Angles that add up to 180. Okay? But it will not be reciprocated. Here's why. Supplementary means they add to 180. So let's say we had 110 degrees, and then we had 70 degrees. Okay? These two angles, are they supplementary? Do they add to 180?
Yes.
Yes. Are they adjacent? No. So they're not a linear pair, but are they still supplementary? Yes. So the only ones, if you circle linear pair, you will always circle supplementary, but you won't always the opposite way. If you circle supplementary, it doesn't mean necessarily that they're also a linear pair. The last thing, help class today is 315 to 345. There's extra credit possible if you do the Kahoot. This is the code. But you must listen to the last two things. You must get a 70% or above. If you get lower than that, you won't get bonus points because you didn't get anything correct. Okay? 70% is a C. That is below average. You must use your real name. If your name is a duplicate name, as in it's a popular name, please put your last name in there. Okay, so that I can know who it is. There's a couple Anthonys. We have two Averys. Put your last name in there somehow if you're going to do this. Okay, so then I know right off the bat. Because if I don't know who it is, I can't give extra credit. Okay? So I'll see you tomorrow.